Hello, I'm back again. So I'm sorry, but I was interrupted by the builder because we were actually in the middle of construction site, and part of the policy of the building is not to allow people to work without hard hats, and I forgot to bring my hard hats. But this building is actually better because this building has some examples detail on the building code, like for example, penetrations to the walls. You can see they're running the air conditioning system, and they have to notch the stud. I will talk about that, but as a rule, you cannot notch more than 25% of the width of the lumber, and they actually have to do a notch on the outside, and that's why they use these plates to protect the ductwork when the drywall is applied. You see, notch to the top plate. It's also detailed on the book. Also, as you can see, some penetrations that they're doing to the, in this case, the building code allow you to work with regular lumber as well as engineered lumber. They're using LVLs for the beams. They're using I beams for the I joists for the floor systems. And as you can see, this engineered lumber has very specific points where you can do perforations. So you can run, in this case, they're gonna run a duct system through these round holes that you can see, okay? So going back to the first lesson, again, this is a house, it has the full studs, skin studs, headers, bottom plate, double top plate, and then of course this is a window, so you have a seal plate at the bottom of the window, and then you get the cripples. Cripples are the only type of lumber that are allowed to be cut on the wall because they have to support the seal plate, right? So the cripples are, but the full studs, again, they have to be full from beginning to end. You're allowed to use regular lumber, or there is another type of lumber called finger joints lumber, where the lumber will have different connections point. The minimum grade that you can use for lumber is number 3, which is on your building code. How do you know the grade of the lumber? Very simple. You can look at the tag, which in this case is graded stud SPF. So this is way better than number 3. I'm gonna point to another opening, so you can see this is another door opening. Again, the same components, right? Trimmers or jacks, full studs next to the headers, and this is interior. Again, this could be done with just a 2x4, but they chose to do a full header, double top plates on the top, right? Intersections here. Let me go around and point to another intersection. This is another intersection technique. Instead of using or building a T, what you do in your normal spacing, which in this case is 16 center, you cross a lattice, which is a scrap piece of lumber, 1x or 2x, to catch the intersecting wall that is coming in this location. You do it every 2 feet, and that's very much. This house also has a 2x10 system. This house is a little bit more advanced, so I'm gonna walk a little bit because it's been inspected already. So you can see some of the points that, like for example, here some notches that is being done for plumbing fixtures, and as you can see, the notches now they're being protected with a metal. Also here on the top plate, you can see that on your code book, and I will point to that. Now some people do short versions of corner partition walls intersection. As you can see, there is a wall coming on the other side, and then it's not falling on the stud, and they just put a dead wood, which is a piece of wood just so that drywall could be attached. So again, now if you realize the joists are running basically on a full run. This is a very narrow house, so it's running from end to end of the other end without breaking. So for that condition, now this wall that you can see right here, which is the outside where the sheeting is located, is considered a bearing wall. You see how it's breaking. And then this wall right here at the other end is also considered a bearing wall. All these walls that they're not running at the same direction, they are considered non-bearing walls because they're not carrying the weight of anything. And that's the reason why, as you can see, they end right there. And for drywall purpose, you cap it or you put another board on the top so the ceiling drywall could be attached to it. But all of these walls are non-bearing walls. So all the headers on this, like for example, this header right here on this non-bearing wall, could be just a 2x4 or a 2x6, you know, but they chose to do a regular header, which is fine. You know, it doesn't hurt. In this case, they're using just 2x6s, so with a 2x6 at the bottom, 2x6s up, standing up, 2x6 at the bottom. So they're doing the technique called, this house, they're doing the technique for small headers. And you can see here on the outside, this is quite interesting because this is the first house that I walk in a very long time. Most people built up headers, but as you can see, in this one, they're doing what on your book is calling for a single header. Single header is just one piece and one at the bottom. It's also on one page. I will call to that page when I do the next part. Single headers, very hard to see it. And as you can see, all these joists, they've been blocked between them, but you can do it two ways. You can do it like this, where they use a rim joist on the other end. That means a continuous board capping the end of the joists. Or you can do it like this, which is a blocking technique. In this case, they're using a blocking technique because this section is a cantilever. That means the floor system is flying out. So they do a force to block between right where the cantilever starts on your wall. So another picture of some plates, some cuts that they've been done for plumbing, as well as air conditioning. And they, of course, you're taking the integrity of the lumber, so that's the reason why they have to use plates. That's mandatory by building code, right? The electrical is not be done, but the electrical also will create perforations. And this is a stairs system. You can see the stairs. Stairs itself has the capacity to support itself, the weight, by the stringers, which is the notch lumber. But in this case, they decide to provide extra support under the stairs by creating a little wall in the middle. These houses are very narrow. Very, very narrow houses, very traditional here in the Decatur area. And this is what I basically want to show you. This is another section that is described on our chapter, which is relating to bracing. Bracing is actually the more difficult part to understand on your book because it has a lot of pages. And basically the majority of the bracing part that is a little bit difficult is because you are allowed to incorporate partial bracing with full bracing. So what is bracing? Basically when you have a wall like that or a building, you know, the wall just by having the studs will rack sideways. And it will rack by many reasons. You know, the wind can blow to it or earth movement. So that's the reason why on your charts, most of them, they are based how much bracing or minimum bracing you need to put. It depends on your wind conditions based on your county and also on your earth movement. And then also you will see some other charts that talk about snow load because it will add more load in order to size your lumber. But in this case, most builders these days, and I will walk outside so I can show you, they're choosing to do sheathing entirely in the entire house. And the reason for that is in your chapters with all the charts that you see that I will explain to you, you can just put some plywood sheeting or in bracing, which is a diagonal 1x4 inside the walls or a metal on just certain points of the house, and the house will keep the integrity. That means it won't rack. Those are called shear walls when you prevent that from racking. But most builders, as you can see, it's quite confusing to do it based on your charts. And then what they choose to do is just they completely plywood the outside of the building. So in that case, everything is, the entire wall becomes basically a brace sheathing, okay? So this entire wall is called brace line, but you can only put on certain points like 4 feet from the corners or 2 feet from the corners, and then the other part changed by a different material like foam boards or some other type of sheathing material. But lately, and you can see in most construction sites, they sheet completely the outside, so that way they don't have to basically go through this number of calculation of how many feet is required to do. But it's very simple. It's just a lot of people don't read the book, the building code book, but as in most applications you can just work 4 feet or 10 feet from the beginning, and then every 20 feet you can put another sheet of plywood. Now, but I will show you that with the actual charts looking at the building code, okay? So now you can see that this is one of the techniques that is described there and he actually there has a diagram about a garage door opening, and as you can see, the header doesn't end where the first jack is located, is actually extending beyond that point, the same thing at the other end. And this works in relation with a brace going up, and also the anchor bolts right next to at the bottom. From the outside, also, this will have a strap. So I will show you on another house, okay? But you can see, this is basically on one of your diagram provided by the building code. And basically, this is a different technique where the header is placed on the right height, and then you cripple above them. That means you put a small short studs, continuing your layout, 16 center or 24 center, for different applications. And you can see, this is a normal construction site where you use conventional lumber with engineered lumber, which in that case will be the OSB plywood sheathing, and also a big LVL that is supporting the garage door header. You see how it looks like it's like a 14 feet wide, 14 inches, I'm sorry, wide. And some other examples that might help you to understand the building code is, for example, for those that took already, you're supposed to be finished with the floor chapter. Every time a joist hit another beam, you have to use a joist hanger, right? There is a lot of blocking for extra support for your plumbing, but this is joist hangers is to provide extra support, right? So let me go through it. Some penetrations, very specific penetration for your ductwork and plumbing, that they're actually breaking through the floor joists. Pipes also going. Again, look at your maximum perforation that is described on the actual book.